Questions 21 to 25 on the 2008 Grade 11 Fermat Math Contest. Suppose n is equal to 1 plus 11 plus 101 plus 1001 plus 10,001, so on, until you get to this number, which has 50 zeros. When n is calculated and written as a single integer, the sum of its digits is. What I'm going to do is write out these numbers in a way that they're all lined up, sort of in a system where we can add them pretty simply. So the very first one is the big long one with 50 zeros. So I'll just write that in here, 50 zeros like that. And the next one is one digit less. So as you can see, it kind of moved over. But it's going to have the same sort of style where the first digit is a 1 and then a whole bunch of zeros, and then the very last digit is a 1. And similarly like that. Now obviously I'm not going to write out all of them. I'll just write out a few of them so you can kind of get an idea of what's going on. And the last few they've already given right there, so I'll just write those in. So this is dot, 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 eventually you're going to get to 10,001, 1,001, 101, 11, and 1. Okay? So now here on the side, I'll write the number of digits. So for this guy right here, that big long number, how many digits were there? Well, they told you there's 50 zeros, right? Right here, they tell you it's 50 zeros. So that means because there's a 1 on either end, in total there's 52 digits for that number. Very similarly, for the next one below it, it has 51 digits. And then 50 digits, 49 digits, and so on, right? And then dot, dot, dot. These ones, well, obviously we don't need to even worry about this. 5, 4, 3, 2, and 1 with regard to the number of digits. So now what I'm going to do is just add them all up. Like this is a simple addition question. And here we go. So just like how you would add up things in your early elementary school days, look at that column. It's all ones, right? But the question is, how many ones? Well, 52, because look at here. We're counting from 1 to 52. So this column is 52 ones. So the sum would be 52. But I'm not going to write 52 there. I'm going to write 2, and then I'm going to carry the 5, right? Okay. So now we look at the next column, which is right here. That column has just a 5, a whole bunch of zeros, and a 1. So that equals 6. And then after that, every single column has just a 1, and all the other numbers are zeros, like that. So this is going to be our number. A whole bunch of 1s and then a 6 and a 2. Well, how many of these 1s are there? Well, all the way across, there's going to be the same number of digits as that top guy. And the top one had 52. So there's 52 digits in this big long number. Well, the first 50 are 1s. So the sum of that, which is what we have to figure out, the sum of the digits, is 50 times 1, plus that 6, and then plus that 2. And this is 58. So number 21, the answer is A. For how many integers k do the parabolas with equations y equals negative 1/8 x squared plus 4 and y is equal to x squared minus k intersect on or above the x-axis? So we can figure out first and foremost this equation, because that does not have any k's in it. So that is y is equal to minus 1/8 x squared plus 4. So when x is 0, very quickly we can figure out that that's going to be 4. And then this parabola points downward. It's going to be like this, right? How do we know that? Well, because this coefficient is negative. Now I need to figure out where it crosses the x-axis. And I do that by setting y equal to 0. And if I do that and solve for x, I will get 4 is equal to x squared over 8. Therefore, x squared is equal to 32. and therefore x is equal to plus or minus root 32. So root 32 approximately here and here. Okay, we don't have to be super accurate like that. Now, this parabola, therefore, is going to look something like this, right? Like that. Now, we've got another one right here, which is y is equal to x squared minus k. Now, this parabola is going to point upward because the coefficient is 1 and positive 1. But then I've got this minus k. So I'm not sure where that k is. I don't know what the value of k is. So the only thing I know is that this parabola looks something like this. And the key is right here. On or above the x-axis is where they need to intersect. So on the x-axis, it would basically be like this. That is the first one. And then all the other ones above the x-axis would be kind of like this, right? And then eventually you're going to have that kind of scenario. And then the very last intersection point is right there, where the bottom of the orange parabola touches the top of the blue parabola. Okay? And we have to figure out all of these. And the condition is that k has to be an integer, which actually helps us. Okay, so let's move forward with this. The first thing, of course, is I'm going to have to make a table. I'm going to have to make a table for x and y. So x and k are what I'm interested in. So the very first thing I want to do is figure out where they intersect on the x-axis. And that's pretty straightforward, because if they intersect on the x-axis, then that means that we can figure out this value by setting x equal to root 32, right? Because that's what happens. That's the intersection point. All right, here we go. So we got to set this equal to this and then work with that. So we've got minus 1 over 8 x squared plus 4 is equal to x squared minus k. All right. Putting everything on one side, we got 4 plus k is equal to 9x squared over 8, like that. And therefore, I guess we can isolate for k, 9x squared over 8 minus 4. So first and foremost, when x is root 32, that's going to allow us to figure out when they intersect on this word right there, on the x-axis. That's a pretty straightforward calculation. That's 9 times 32 over 8 minus 4. That looks like 9 times 4, which is 36, minus 4 is 32. So k is 32. All right, so we got 1. Now we have to figure out all the integer values. For k, x does not need to be an integer, obviously, right? But k must be an integer according to my conditions in the question. Okay, well, instead of going k31, k32, 30, 29, that's obviously going to take forever. I'm going to jump all the way to the other extreme, which is when they intersect, but in the last possible way, which is the very bottom of the orange parabola touches the very top of the blue parabola. That would be the last intersection point as this parabola is going up, right? And like I said, the accuracy, don't worry about the accuracy of this diagram. These parabolas actually would not look like that. I'm sorry about that. I mean, they're not going to look like this, right? The parabola is going to look exactly the same. So if this one was like this, the other parabolas will all look the same. They would just be shifted up. See what I mean? Yeah, so I just wanted to illustrate to you that there's going to be intersection points higher up. So don't worry about that. Just concentrate on trying to find integer values for k. So there's going to be 31, 30, ... But eventually we're going to get down to the very last one. And the very last one is when we have that intersection point. So how do I figure that one out? Well, that one occurs when k is equal to minus 4. Now, how do I know that without figuring out anything in here? Well, because this equation y equals x squared is essentially just like this, and it's going up or down depending on the value of k. If k is minus 4, this becomes y is equal to x squared minus 4, which is y is equal to x squared plus 4. So that means that it would basically be right here, where this is 4 right there. Okay, so minus 4 is the very last one, and just if you're wondering, the x value when k is minus 4, the x value will be 0, right? You can use this equation to figure that out. And therefore, you're going to have integer values all the way from k equals 32 all the way down to k equals minus 4. So minus 3, minus 2, minus 1, 0, and then 1, 2, 3, all the way up until 32. So 1, 2, 3, all up until 32 obviously is 32. And then these guys, there's 5 of those. So we have to add 32 and 7, and that's 37. 32 and 5. So there are 37 integer values for k, which allowed these two equations to intersect either on or above the x-axis. So the answer, number 22, is E. Square PQRS has side length 4. Point U is on PR, with PR equal to 4UR. A circle centered at U touches two sides of the square. PW is tangent to the circle with W on QR. The length of PW to the nearest thousandth of a meter is. In a step-by-step way, let's try to figure this question out. So, the first thing I want to do is figure out the length of PR. So this distance all the way across. And PR squared, I can use Pythagoras, is 4 squared plus 4 squared, because they tell me that the side length is 4. So I'm just using Pythagoras. And therefore PR will be, PR squared will be 32, and therefore PR is root 32, and that is also equivalent to 4 root 2. Now, the next piece of information is that PR is equal to 4UR, so we can very quickly figure out what is UR. PR is equal to 4UR. PR is 4 root 2, 4UR, and therefore UR is equal to root 2. All right, so far so good. Now what I want to do is, let's see here, where should I go next? I want to figure out the radius of this circle. So from there to there, from there to there, right? From there to the tangent point. Those are all equivalent. Those are all radii. I'll just label that small r, since we already have a big R. Now keep in mind, this is not the radius. All right? I mean, you guys know that, but just wanted to point that out. So to figure out the radius, UR squared is going to be r squared plus r squared, right? Using this triangle right there, using Pythagoras on that triangle. Because this is r, and therefore that is also r from here to here in terms of its distance. Solving for this, we got 2 is equal to 2r squared, and therefore r squared is equal to 1, so therefore r is equal to 1. Okay, great, it's a nice number. And then let's see, what else should I figure out here? I think figuring out the distance from P to U might come in handy. So PU is equal to PR minus UR. PR we just figured out was 4 root 2. UR we just figured out was root 2. So PU is equal to 3 root 2. So far so good, I think. And then now we yet again will have another Pythagorean relationship. This one, got to be a little bit more careful here. Notice they tell you in the question that PW is tangent to the circle. So this line is tangent. That means that the point that it touches the circle forms a right angle. So this is a right angle right here. Okay? And so I know that I don't know, maybe it's the way I drew it, or maybe it's the diagram, but it may not look perfect. But of course we know that is true, that it is a right angle since PW is tangent. So because it is tangent, we can figure out a Pythagorean relationship. Now this point here, that point right there, I'm going to label it something. I'll just use T. So that means that PT squared plus TU squared is equal to PU squared. Okay? So so far there's no tricks here. You know, this is just straight Pythagoras. As long as you don't make any silly algebraic mistakes or silly Pythagorean mistakes by putting the hypotenuse in the wrong direction or the wrong side of the equation, you shouldn't have any problems. Because obviously they're anticipating common errors, and that's how they figure out the answer choices. All right, here we go. PT squared. TU is just R, and R is 1. So 1 squared. And PU, we just figured out, was 3 root 2. So this looks like 9 times 2, which is 18, minus 1 is PT squared. And therefore PT is equal to root 17. All right, great. So we're making excellent progress so far without any tricks, anything that's beyond so far Pythagoras. Okay, so now is the point of the question, which is sort of the final step, that not necessarily very difficult, but it takes a little bit of thinking. And it first involves drawing a line from the center of the circle to W, like that. Okay? And then I'm going to label a few things, if I can squeeze them in here. This distance right here, I'm going to label X. It's from here to here. And this distance right here, I'm going to label Y. There we go. I hope you can see that right there. And then from those two, I can get a little bit of a relationship. A few more things need to be labeled, however. The distance from here to here is the equivalent of R, which is 1. We calculated that over here. And then I just labeled this X. So the distance from here to here, basically from Q to W, is going to be 3 minus X, right? Because the whole distance is 4. I hope that's clear. And then, what else can I label here? PT we got is root 17. And PU we have a whole bunch of stuff, so we can go with this. So let's first figure out the Pythagorean equation for that triangle. My equation will be 3 minus x squared plus 4 squared is equal to root 17 plus y all squared. And that is the Pythagorean relationship of this triangle right here. 3 minus x is one side, 4 is one side, and then PW is PT plus TY, which is root 17 plus y. This is the equation that will help us solve for y, and once we do, we can figure out PW. The only problem is that we've got two variables. So obviously, we have to figure out x in relation to y. Well, that's where this comes in right here. And let me blow that up a little bit. Right there. This right here. It's a little small, but you can see it. Well, these are right angles. That's a right angle, that's a right angle. So that means that y squared plus r squared is the same as x squared plus r squared. Right? Those are Pythagorean relationships. Y squared plus r squared is equal to that green line. And then x squared plus r squared is also equal to that green line. That's why I set them equal to each other. And therefore, if you remove the r squareds from both sides, you get y squared is equal to x squared, and therefore y is equal to x. And some of you also know that that's also true because they're tangents to the circle emanating from the same point, and that point is W. So Either way, y is equal to x. So because y equals x, that helps us tremendously. We can substitute it in there. There we go. Now we have everything in terms of one variable, and we can expand and solve. So here we go. So we got 9 minus 6y plus y squared plus 16, and this is going to be 17 plus root 17 times 2y plus y squared. Y squareds cancel, and let's see what we can get. Everything on one side, 2 root 17y plus 6y. And if you bring everything over, 9 plus 16 is 25. 25 minus 17 is 8. Okay. Hopefully I haven't made any errors. So now I can factor out the y, and this gives me 8 over 2 root 17 plus 6. And therefore y, 8 over 2 root 17 plus 6, if I do this in my calculator, I get 0.5615. All right. So final step, I've got to figure out PW. Well, what's PW? Let's go back to our diagram. PW was all the way from there to there, right? PW is PT plus TW. PT we just figured out was root 17, and TW was y, and we just figured out y. So PT plus TW, PW is equal to PT plus TW. PT is root 17, TW I had labeled y, so this is root 17 plus 0.5615, like that. And if you do the math, this becomes 4.684. 4.684, let's see. 4.684. The closest one is C. We're off by a little bit, but that's okay. Let's see here just to make sure. Yeah, all the other ones are quite a bit different. So 23, the answer is C. So I just want to make a quick point here. If you're in grade 11, chances are you're not going to make this mistake. But those of you that are beginners, just the biggest piece of advice for Pythagoras is something that even the best of us can make sometimes when rushing, is that if you have A, B, and C, A squared plus B squared is equal to C squared. But what happens sometimes when you're rushing is you might do C squared plus B squared is equal to A squared. See what I mean? Getting that mixed up. And then if you do that, of course, you'll get the wrong answer. So when you're doing a whole bunch of Pythagorean relationships like we did, just ensure that you obey this rule that the hypotenuse has to equal the sum of the squares of the two other sides. The number of triples ABC of positive integers such that 1 over A plus 1 over B plus 1 over C is equal to 3 over 4 is... The first thing we need to do is make a table, and off we go. Got A, B, and C. So this is going to take a long time, unfortunately. It's a tough question because of the time requirement, not so much because of the math. The math is just a bunch of fractions, which is, elementary, but just the time, all the time required. So the speed of how much you can do in a short period of time is really the determining factor of your success on this question. Because if I had said, okay, take this home for the weekend, no problem, right? You got the whole weekend to do it, but you've got like less than 5 minutes, sometimes not even 5 minutes. So here we go. Case by case. First and foremost, I've got to start somewhere, right? So let's start with 1 because it's the smallest possible positive integer. If A is 1, 1 over 1 plus 1 over B plus 1 over C has to equal 3 over 4. And that's impossible because it would make this side 1 over B plus 1 over C, but then this side would become negative a quarter. And there's no way you can get negative a quarter with two positive numbers. So what that essentially means is that A cannot be 1. No problem. Let's make A equal 2. If A is 2, we've got 1 over 2 plus 1 over B plus 1 over C is equal to 3 over 4. And then if you subtract this, you get A is equal to a quarter. So now I turn my attention to what B can be. I've set A as equal to 2. I can see that that is legitimate. All right, let's go with that. Immediately I notice that B must be greater than 4. Why? Because if B is 4, then C would have to be 0, and that's not allowed. If B is 3, then C would have to be some negative. So B must be greater than 4, so let's start with B equal to 5. If B is 5, you put it there. 1 over C is equal to 1/4. And if you do the math here, you get 1 over C is equal to 1 over 20. Therefore, C is 20. All right? So as you can see, this is the painful process we have to go through for this question. And I'm not going to go through every single one. What I mean by that is I'm not going to go through this whole thing for every single one. Because, I mean, you guys definitely know how to add and subtract fractions. I don't need to walk you through that. I'll just show you the process in terms of how to calculate all the triples. Again, we use 2 for A, and then we choose 6 this time. We're just going up one by one. If you use 6, you get a value of 12 for C. Okay, so far so good. Again, we have 2 fixed for A. We choose 7 for B. If you choose 7, we do not get an integer value for C. So that one doesn't work. Keep on going, 2 and then 8. If B is 8, we get 8 for C. All right? And then you just keep on doing this, and eventually what you'll notice is that you get up to 2, 12, and 6, and 2, 20, and 5. And you say, well, do I really have to go through every single one? And the answer is no, you don't. You just have to understand that just how this is 5, 6, 7, 8 like this, that's going to be the same for this one. 5, 6, 7. So you saw here that I did 2, 8, 8, but then I didn't do the 7 for C because that doesn't give an integer value for the other one. And then I did 6 because I got a 6 here. I did 5 because I had a 5 here. So those can be reversed. All right? So that takes care of A equal to 2. Now we move on to A equal to 3. If A is 3, then in a very similar way, we've got 1 over 3 plus 1 over B plus 1 over C is equal to 3 over 4. 1 over B plus 1 over C will be equal to 5 over 12. To start choosing values of B greater than 2. So B has to be greater than 2. So let's choose 3. If I do, I get 12 for C. Solving in that equation. A is fixed as 3. Let's go up to 4. If it's 4, it's 6. A is fixed as 3. Let's try 5. If it's 5, I don't get an integer value. If it's fixed as 3 and it gets 6, well, it's the exact same as this. We just reverse it. And similarly, as you're going up with B's, you're going down with C's, and the only integer value of C less than 4 that works is 3. And that gives me 12. So you see how we can avoid doing every single value by looking at the fact that B and C can be reversed. Okay, we're making good progress, I think. Now we get to A equals 4. So we have 1 over 4 plus 1 over B plus 1 over C is equal to 3 over 4. And therefore 1 over B plus 1 over C is equal to 2 over 4, which is a half. All right, that's pretty good. So where do we start? Again, B must be greater than 2. That's the only way this is going to work and give integer values that are positive for C. Okay, so we start with 3. If B is 3, C will calculate to be 6. 4 is fixed for A. Now we go up to 4. And C becomes 4. It's 4, 4, 4. And then A is fixed as 4. We go up to 5. It doesn't give an integer value. A is fixed as 4. Now notice, as we're going up one at a time with B, we're going down with C. So the only value of C less than 4 that works is 3. And that gives a value of 6. So, as you can see, I got a few more there. And the good news is we only have a few more left. The next one is going to be 5 as my fixed value for A. So 1 over 5 plus 1 over B plus 1 over C is equal to 3 over 4. And if I do the math, I get 1 over B plus 1 over C is equal to 11 over 20. Obviously cannot be 1, so the smallest it can be is 2. If I choose 2, I get 20 for C. And when I start plugging in values of 3 and 4 and 5, I never get an integer. The only time I get an integer is when you have just the reverse of this. So 2 here and 20 here. All right. And then finally, we've got the situation where we are now up to 6 for our value of A. So 6. So we have 1 over 6 plus 1 over A. Sorry, 1 over B plus 1 over C is equal to 3 over 4. And therefore 1 over B plus 1 over C is equal to 7 over 12. All right, so again, let's start with 2. If we get 2, we get 12. And then the only other value that works is 12 and 2. So there we go. We've got all the possible ones. And then after that, it doesn't give us any solutions in terms of integers for anything for greater than 6 for A. Now, you say, okay, let me count up my integer solutions. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, 16 is one of the answers. But not so fast. Please do not circle that. Why? Because each of these has different combinations, correct? Like this one, there's 6 possible combinations. What do you mean by that? Well, 2, 5, 20 can also be 2, 20, and 5. It can also be 5, 2, and 20. It can also be 5, 20, and 2. It can also be, let's see here, 22 and 5 and 25 and 2. You see how they can be rearranged? So that gives me 6. Similarly, this guy gives me 6, right? And this one, be careful, it doesn't give me 6, it only gives me 3, right? Because you got 2, 8, 8, that can only be arranged as follows: 2, 8, 8, or 8, 2, 8, or 8, 8, 2, because 2 of the numbers are the same. Okay, now we have to be very careful. 2, 12, 6, this is exactly the same as that. It's already counted. The biggest problem in this question, well, maybe not the biggest problem, but one of the problems is overcounting. You're counting something that's already been counted. So this one will not give me any new combinations. Similarly, this guy, it's already been counted up here. So no new, 0. Got it? All right, so let's keep going here. 3, 3, 12, this gives me 3 combinations. 3, 4, 6, this gives me 6. But this guy gives me 0 new combinations, and this also gives me 0 new combinations because we've already counted these in this and this. Okay, moving right along. This one gives me 0. Why? Because 4, 3, 6 is the same as this one. You see what I mean? See, it's kind of tricky. 4, 4, 4, okay, that is legitimate. That's new, but I only get 1. There's no way of rearranging that. It'll be exactly the same. This gives me 0. Why? 4, 6, 3 is the same as this guy. And then 5, 2, 20 has already been counted up here. So that gives me 0 new. 5, 22, again, 0 new. And 6, 2, 12, that's got to be somewhere earlier. 6, 2, 12. Yeah, right here. So that gives me 0 new and 0 new. So the only ones I need to count are those guys. So that's 6 plus 6, 12, plus 3, 15, plus 3, 18, plus 6, 24, plus 1, 25. 25, write it big here, is the answer to my question, and that is choice B. A right regular hexagonal prism is sliced as shown in the diagram. The bottom of the new solid is a regular hexagon A, B, C, D, E, F. The 6 side faces are trapezoids perpendicular to A, B, C, D, E, F. The top is a hexagon U, V, W, X, Y, Z that is not necessarily a regular hexagon. Of the 6 edges A, U, B, V, C, W, D, X, E, Y, and F, Z, 3 have lengths 4, 7, and 10. The largest possible value for A, U, B, V, plus C, W, plus DX, plus EY, plus F, Z is... This diagram, of course, is the heart of the question, and we will concentrate on this diagram. The first thing, of course, is we have to figure out some sort of a relationship. And I'm going to draw a line from U to X right there. And similarly, I'll draw a line from V to Y and Z to W. And sorry, this is not perfectly drawn to scale, but the point is that the very middle point is the midpoint of all of those lines. It's the midpoint of the line from U to X, the midpoint of the line from V to Y, and the midpoint of the line that supposedly is supposed to go from Z to W. It's kind of hard to draw it perfectly because it's on a slant, so that's okay, but you understand. M represents the midpoint of those 3 lines. Now, I'm going to use a little bit of a notation, don't get confused, that I'm going to talk about the heights. So the height, for example, from the base to U, which is right there, I'll just call the height U, like that. Okay? So for example, this is the height U from here to there. And very similarly, I'll do the same thing for all the other guys. So for example, the height from the base to X is going to be HX, like that. Okay? So let's first just talk about HU and HX. If you add them and divide by 2, you will get the height of M, right? The distance from M to the base. That will basically be the distance of HX and HU divided by 2. Why? Because M represents the midpoint. So I hope you're convinced of that. If you are, we can move forward. Similarly, we can use the other 2 to figure out HM. And I'll use V, which will be HV from there to there, plus the one that's opposite, which is Y, HY. HV plus HY divided by 2 is also equal to HM. And in a very similar way, HM is also equal to HZ plus HW. So we got HZ plus HW all divided by 2. Okay? So far so good. Hopefully nothing too tricky so far. Now what we do is we just add them. Add them all. And if you do, you get 3HM here. And over here, you get the big long thing divided by 2. And if we, put everything on one side, you get 6HM right there. But then each of these corresponds to each of these, right? I just wrote it like this to help you understand that those are heights. But HU is essentially the same as AU, right? HU is AU. That's basically what it means. I wanted to just illustrate that those were heights. That's why I used H. But then we can convert it back once you understand. And similarly, so that takes care of this guy. HV is BV. And then HW, which is this guy, is CW. And then HX is DX. And then HY is EY. And finally, HZ is the same as FZ. So we basically have exactly what they wanted. And we got it all in terms of HM. So if we can figure out what is HM, we're done. We're done with the question. But finding HM is a little tricky. There's a few cases, and I'll talk about 2 of them. And then you'll see how one gives a value that is the maximum, one gives a value that's not the maximum. So the first one is considering the fact that 3 of them have been given as 4, 7, and 10. All right, so I'm going to do the first one, which in my opinion is the most obvious, which is that AU is equal to 4 and BV is equal to 7 and CW is equal to 10. That's probably the most obvious one. All right, let's figure this out. If this is the case, then we can figure out HM with any of these guys here. Okay? So I can just use, for example, this one right here. So that would mean that HV plus HY over 2 is equal to HM. Well, HV is the same as BV, right? The height from V to the bottom is the same as BV, this guy right here. So BV I have to call 7. Well, HY, what is HY though? Well, HY is from there to there, but we don't know that. But because of the way I've labeled it, I'm basically saying that this is the same height as that. Okay? So that if you were to look at it from this angle, that it's not tilted. You see what I mean? Z is on the same level as V, and then Y is on the same level as X. Okay, I hope that makes sense. And therefore, since it's not tilted, that means HY is the same as HW, which is CW. So we get 7 plus 10 over 2 is equal to HM. And therefore, HM is equal to 17 over 2. So therefore, going back into here, 6HM is my value for this whole thing that I have to figure out. So that's 6 times 17 over 2. And that is equal to 51. All right. 51 is one of the answer choices. But is it the largest possible value? Now, that is the tricky part to this question. You don't know. Do you take a chance and circle it? And unfortunately, 51 is not the largest. It is a possible value, but it's not the largest possible value. Okay, so how do we get the largest possible value? Okay, this is where that whole thing about tilting comes in. So if I were to look at it from that angle, it's not completely the same in terms of lengths. Like V to the bottom is not the same as Z to the bottom. It's tilted. So how do I explain that? I'll just draw a little sketch. Before, it was not tilted, right? So if you're looking at it from this point, it would look like this. Here's U, here's V, here's Z. And if you go a little higher up, you would get to Y, and you will get to W. And then, of course, they all meet at X. Correct? But this can be tilted. So it means that instead of these being uniform in terms of its length from the bottom, they could be tilted like this. So if we're making a comparison, now V is here. See what happened there? Top to bottom, V is there, and now Z is here. It's no longer completely uniform so that the distance from the base to V and the distance from the base to Z is the same. And then we've got this sort of scenario here. Does that make sense? Or this is now W, and this is Y, and this is X. So that tilt is very important. And if you do that tilt, you can come up with another scenario. And that other scenario is as follows. This time AU can be shifted to be 7, and then BV can be made to be 4, a little bit shorter, and then CW, we can keep that as 10. All right, so I hope that makes sense. We just shifted it so that we kind of just, what we did was we lowered V down a little bit. Okay, so we have to work with this now. Now I want you to look at MW, which is right here, and compare that to UV, which is right there. Those two are parallel. So I'll write that over here. And because MW is parallel to UV, the height to M, which is basically HM, if you subtract from that the height HW, so basically we're taking this height and subtracting it from that height, it'll be the same as the height U minus the height V, which is this height minus that height. And therefore, using these values that I've just selected by rearranging the numbers a little bit, I can figure out what is HM. HM will therefore be minus HW, which is the same as CW, which is 10. HU is 7, and HV is the same as BV, which is 4. So this gives me HM is equal to 3 plus 10, which is 13. So I take my value of HM equals to 13, and I come back to my original formula and get rid of this guy, because we need to figure out something new. And then I take HM equals to 13 and substitute it. And if I do, I get 78. And that is the largest value that we can get. Interestingly, if you were to look at this diagram, if this is your selection, then the other ones will be 19, 22, and 16. And the way I got that is just by these relationships right here. Not that you really need to, but just to kind of make the question complete. So it's a challenging question. I think the hardest part was the tilt. I'll write that in there. The tilt involving this top face or the top polygon when you look at it from the viewpoint of that direction. So the maximum is 78, and therefore the question 25, the answer is D.